Thank you for being with us today. We appreciate you joining myself and Iggy Brigado, JPS Senior Solutions Engineer, for this very important webcast. We're going to talk about the JPS SNV-12 signal noise voter. We want to address some of the more common questions that our customers have when they're in the process of upgrading their voters and voter systems with an IP backhaul. So let's go ahead and get started, Iggy, and see where we can go in helping our customers out when they're wanting to upgrade to an IP backhaul, and maybe do it without a lot of troubles. Or
Yeah, I think we want to keep this. We're gonna do this a little different, I guess, Carol. I would
yeah,
try not to be as technical as we typically are, but I think what we want to do, I think what you're interested in doing is maybe answering some questions or answering some of the concerns that I think some of our customers have
right.
related to IP backhaul.
Yeah, no. From a sales perspective, one of the questions that we always get is, "I don't think I have the funding for this," and we don't think we can get around to upgrading to IP backhaul at this time. But actually, it's not that expensive, is it?
Yeah, no, it's not. So before we get started, yeah, I kind of want to talk about a voter a little bit. I'm not going to dive deep into the SNV-12 because it could. I mean, we could be here all day, as you know, Carol. But I just wanted to show you a couple examples of what the voter is, and that's really going to help kind of set the stage for our IP backhaul discussion. And so, Carol, I got a really simple example here. A voter, or a comparator, as it's often called, is used to allow multiple receivers to extend our receive coverage area. So by installing receivers throughout my operational area, I can backhaul that information to what we call the voter or a comparator. We assess the quality of that audio from those many different receiver sites and then vote or select a single site. So this is a good example of how we can backhaul that information to the head end voter. We've got a subscriber unit, as you can see here on the left, transmitting, and several receivers are receiving that information. And we select the best audio based upon quality, not how loud the audio is, but the quality or the least amount of noise. And then we negate the other receive sites. We vote that information. We have two choices. We rebroadcast that information back out to the field and or send it to the console for more back and forth conversation. So this is really a basic solution to extend our receive coverage by using a voter, or sometimes we call it comparator. And so these are the traditional backhaul links. Analog backhaul links obviously include lease lines and T1 microwave, and there's still RF links being used to backhaul receive information back to the head end voter. And there's also IP backhaul solutions as well that can include digital microwave, terrestrial fiber, Ethernet, or what have you. But that has some of its challenges, and that's what our discussion, I think, here today will be, Carol, talking about transitioning systems from an IP backhaul perspective to a digital perspective, which a lot of our customers have trouble kind of visualizing.
I agree, Iggy. I've heard that some existing SNV voter customers may be skeptical of the JPS IP backhaul solution. How do we respond to that question?
Yeah, that's. I mean, I think what a lot of customers imagine this solution as being very expensive, requiring GPS or timing references, which it doesn't, which is kind of remarkable. So it's almost like magic when I first was introduced to it, to this solution. Yeah, I think it's important to explain the technology to the customer and explain it in a non-complex manner, because a lot of our customers believe that you need expensive GPS timing, timing sources, network timing protocols, timing references, which can be expensive, delay lines, and things of that nature. But it's actually pretty simple. And I think just by explaining to the customer, I think we can allay a lot of those uncertainties in the customer's mind. So,
Iggy,
mhm.
Iggy, some of our customers have been using the same method. Primarily, is lease lines. They've been using those for a long time, and they're either going away or they're becoming very expensive, and they don't exist. How well is it when they start to integrate in with our product, our IP backhaul, to move it over to our system?
Yeah, it's pretty simple. So, let me show an example of the IP backhaul solution from JPS and show you how simple that is. And it can obviously be very complex for some of these larger systems. The solution will actually support up to 60 receiver sites. Yeah, let me show you a couple examples: analog backhaul versus IP backhaul. IP backhaul done the proper way, and really IP backhaul done, I believe, the incorrect way. But this is an analog backhaul links coming back to the head end voter. I've got a subscriber unit transmitting out in the field, and in this case, I have several receivers receiving that transmission from the field being delivered over the analog links. And as you can notice in the diagram, one of my links is sort of late in delivering the audio to the head end voter. And so some of the symptoms that we would hear or experience is an echoing or picket fencing. But in all cases, what the voter is doing is it's doing its job. Because the audio is late, the voter is going to select that site or vote that site and then retransmit or send that to the console. But because the voter is going to do its job, once that audio arrives at the voter, it might notice that audio is not of great quality, and it will jump to another site, and that's what the voter does. And so the symptoms is that there will be some sort of echoing or a loss of those first few syllables of the field transmission. And again, that is because of propagation delay or process delays of devices within the system. And this is analog backhaul. And so the resolution would be to adjust the receive audio delay inside the site voter module. Those are the individual site voter modules in the SNV-12 chassis. We can have the other early arriving data arriving to those modules buffered inside those modules, allowing the late arriving site to arrive, and then we can vote at the same time, thus preventing the echoing or the loss of first few syllables of the field transmission. So this is an example of analog backhaul. In an IP backhaul example, and this is an example of how our customers have deployed IP backhaul in many years ago, 20 years ago, when the NXU2 and the NXU2A were available from JPS. And so a lot of those smart people thought that maybe I'll take a device like the NXU or a third-party device that can convert analog audio into RoIP data. I can deploy one at my receiver sites, and then I can deploy a RoIP conversion device like an NXU at the head end voter, and then now I can take advantage of IP networks, which is a great idea. And so this has been done for over 20 years with lots of good success at a lower capacity level, but at some customers that deploy at a higher capacity see issues. So here's what's taking place in a backhaul solution, which is digital or IP. And again, this is not a great solution, and we'll see why. And so same scenario, we have a subscriber unit that's going to transmit out in the field. We have several receivers quieting and delivering that information, the RoIP information, that digital information, back to the head end voter. We hopefully convert that back into analog content and allow that to be delivered to the voter for noise assessment or quality assessment. As you can see in my diagram, however, one of the sites is latent again. And again, the symptoms would be the echoing or the loss of the first few syllables. And again, that is due to network latency. Again, that's propagation delay or process delay. And so the resolution would be the same as an analog backhaul link. We would adjust the receive audio level and be on our way. So over time, and this could be just a few minutes, an hour, or through the course of a day or several days, the network begins to load and saturate in different ways. This is what we call latency. Over time, we call that jitter. So if we look at that same example, we have another subscriber unit transmitting out in the field, and this could be a few minutes later or an hour later or half a day later, but that information then gets converted to RoIP, delivered over the network. And as you can notice in this example, that another link is exhibiting propagation delay due to network latency. Again, we do have a resolution. We can adjust the receive audio delay of all the other modules. such that they are perceived as arriving at the same time, but this is going to be futile as the jitter takes effect. We're going to have to be constantly making that adjustment. So the other issues that we see with traditional IP backhaul, again using maybe NXUs or third-party RoIP conversion devices, is the effect of the compression. Whether you're using a MULA vocoder or other compression algorithms, we have to sample the analog audio and then turn that into digital information. We deliver that over the network in the form of RoIP, and again, hopefully recover that at the voter end, the head end, and convert that digital information back into analog information. And a lot of times the effects of the compression doesn't fully represent the quality of the audio being received at the voter, and sometimes noise is misrepresented, which then equates to misvoting. So there's a lot of things going against us when in terms of IP backhaul. That's jitter and the effects of the compression or the quantization error of the vocoders as perceived by the voter itself. So the IP backhaul solution is pretty interesting, and this is again how we should be explaining to customers how that solution works and how simple the methodology is, and really a low-cost solution. A low-cost solution that is integrated into a chassis as opposed to other devices that are assisting the voter and are not tightly integrated into the system. So in this example, I do have some analog links, and the SVN-2 modules in the chassis support receiver or transmitter sites on a one-to-one basis. So one SVN-2 will support a single site. If we deploy SVM3 modules, now we have an IP backhaul solution tightly integrated. Those are modules that live inside that chassis and communicate with control processor module in the chassis. We deploy remote QMT1 modules at the receiver site, and now we have ability to use timing. And for instance, what we do is we can send a timing protocol, which we call a time sync refresh, from the CPM module and share that information with the SVM3, which is a digital IP backhaul module, and the remote QMT modules, analyzing and understanding the virtual path length or the symmetrical distance in time between all the components in the system. And those components also include the remote QMT module. Now, what happens is, whether we have IP backhaul mixed with analog backhaul, which we see here, you can see that one of the digital links is late, delivering its RoIP data to the voter. But what the voter will now do is automatically adjust the audio buffers in the SVM3s to compensate for that jitter on a timely basis. Every 60 seconds, for instance, it's reassessing that virtual path length, and now we're voting properly. We're not misvoting. We're not producing that echo or missing that first few syllables. So I think just by explaining to the customer this type of scenario, how that time sync adjusts the internal buffers is, I think, significant in getting those customers on board with this IP backhaul solution. Like I mentioned, Carol, that's a fully integrated solution. Modules are inside that chassis, which I think is a great advantage.
Iggy, we have a lot of customers that ask, they say our agency loves our existing SNV voter, but I don't think we have the budget to deploy an entirely new SNV-12 with IP backhaul. And I think we have a lot of different responses to that where we can help them out. Would you agree?
Yeah, because I think some of those customers are looking for other solutions, as I mentioned, some of those third-party or external solutions that function between the voter and the network and the receiver sites. And so some of those can be rather complex, and some of them might be costly. But again, explaining how the technology works is a good start. But one thing I think what we do, and we express this very well to customers, is that they can continue using their existing chassis, the existing the SVM2 modules if they're still supporting analog backhaul links. They can support CPM. If they have a CPM3 module, they can reuse that module and the power supply modules, the CIM console interface module. So really, in essence, they are going to retain the functionality of that entire chassis, and maybe just introduce one SVM3 and maybe a couple QMTs just to get started. And I think we've seen that in the past where, customers want to kind of test that water and maybe do one or two links and still retain the complete functionality of that voter, still have analog backhaul links, which I like calling a hybrid system. But I think that's a good approach, telling the customer that they do not have to depopulate their racks, and they can keep that SNV-12 chassis mounted to that rack, still use that power supply module, control processor module, if it's an SVM3, or excuse me, a CPM3, still use the console interface module, and still retain that same functionality. So, but I think a phased approach is really a good
I
way
agree.
of getting
I
customers.
agree.
I mean, what have you seen, Carol? What do you think?
I've seen the same thing. When a customer finds out that they don't have to do a forklift on their existing system, they can use the same chassis. It really makes it a lot easier for them to do that. The cost is reduced for them. Yeah, it makes all the difference in the world when they find that out. And we've also heard from customers that's been using the NXU2A
Oh yeah.
modules to support one of our remote receiver links. They say we want to go 100% IB, but maybe we should just deploy more NXU2 modules.
Yeah.
What's your response to them with that question, Iggy?
Yeah, I mean, our IP backhaul solution has been around, gosh, for a while, well over 5 years. Um, but there are those customers back in the early 2000s that were deploying NXU2s or NXU2As to create that RoIP backhaul link from the remote receiver site back into the head end voter. And we've seen customers, I know customers that have done that and with a lot of success. If they're maybe doing supporting one or two links with NXUs, I think they're okay. The jitter, they can tolerate the jitter, or they can tolerate the misvoting. But we do have customers, and I'm not going to mention them, that have done full deployments with NXUs with not great success. They'll suffer with a lot of echoing, loss of those first few syllables. But again, I think again we need to explain to the customers how that technology works. You're still using JPS RoIP to deliver that information, so if, you got that reliability of self-healing RoIP links back to the voter head end. But yeah, we still get customers that are used to voting using NXUs. We just need to educate them and kind of explain, the whole effects of jitter and how that affects the proper voting, as well as the quantization error of the vocoders that are used to compress that audio, so we can allow that the minimal use of bandwidth on the network.
It just moves it up another step, and it really helps them with their system immensely.
Yeah.
We've also heard that would it be possible to test the JPS backhaul solution on my existing active SNV-12 voter system without disrupting communication? That's a good question. For most of our customers, any of those that are involved with it on a daily basis, how would you respond to that question, Iggy?
Yeah, I hear that all the time.
Yeah.
Yeah, because I think they're afraid to touch that existing system, which is in a lot of cases have been running straight for 2 decades. And that's one of the attributing factors of success of the SNV-12 voter is its longevity. I mean, we've had this product line since the early 90s, and we have voters out there that have been running for 2 decades, never running 24/7. So that you look at that reliability, and I know we have customers that are afraid to just even touch the voter once it's running. So again, explaining the technology, demystifying that technology, I think is a big deal. So we've had a lot of customers approach us with that same question, Carol. How can I test this on an active system, and is there a way I can recover from that type of evaluation? Right. So I'm going to show you a really good example of again how I can take an existing system, and you can see on here that we have a single JPS SNV-12 chassis. And one thing I kind of wanted to mention is a chassis signifies a single conventional radio channel. So if I had an agency I'm dealing with and they have 5 conventional channels that they want to vote, they're going to need 5 SNV-12 chassis. So the chassis is a channel, and each of the SVM2 modules in this case are, which we call the site voter modules, SVM. Those will support a remote receiver / transmitter site. So it's on a one-to-one basis. And we have an analog backhaul. So this might be depicting a existing customer system. The existing customer system might have even a dual or a triple chassis type solution, but nonetheless, they're all the same, except they're obviously larger or higher in capacity. But this is an example of a single channel, 12 site analog backhaul solution. And so explaining to the customer how simple this is, you can start with the fact that all you need to do is start with that control processor module. And as I mentioned just earlier, Carol, that the voter chassis can be retained. It's fully functional in an IP backhaul solution. The power supply on the left, the CIM2A module at the left as well can be reused. And the control processor module, if it's a CPM3, can be reused. But if it's a older voter that has a CPM1 module, that will have to be replaced with a CPM3 module. And so for those that are interested and that they might already have a CPM3 module, all you need to do is update the firmware version in that CPM module with v.3 version, downloadable from our website free of charge. That sometimes scares the customer. And so I've had a couple customers where if they're moving from a CPM1 to a CPM3, I tell them maybe purchase a CPM3. You can run that CPM3 in IP backhaul mode or a configuration. And if they want to back away from that, which I'll tell you never happens, they can reinsert that CPM1 and get back up and running. And so that control processor module 3, that CPM3, is important because that has a network interface and it has to communicate to other modules that are part of that singular channel. The next step in the process is connecting that control processor module to the network. That has lots of benefits, obviously communicating with other modules, but this is a great way of updating your system, is the ability to engage the CPM3 or the entire voter for that matter using a web-based browser, and you can take a look at statistics or the health of the chassis, control some aspects of the voter, and monitor statistics of that voter just by logging into that control processor module. So just that in itself, I think it's a big benefit to SNV-12 users out there. The other thing you need to change, transitioning to an IP backhaul solution, is to swap out one of the SVM2 analog backhaul modules with an SVM3. If you have a chassis that's not fully populated, that's even better. You have an empty slot, slide in that SVM3, and now you can slowly prepare for that IP backhaul solution. Connect that CPM3 module to the network. And what's interesting about the SVM3 module is if you look closely, I think it's hard to see here, but there's 3 of everything. There's 3 mode switches, there's 3 sets of voted LEDs, 3 sets of unsquelched LEDs, and that's because that module can support 3 sites. So that's, if you look at the SVM2, it's a 1-to-1. We can only support 1 site. SVM3, we can support 3. And when we pair a QMT module with the remote receiver or transmitter site, we can then close that network link with the voter. And remember, we're going to send that time sync signature information back and forth between all the modules, assessing the latency or the propagation delay of the network, and then adjusting the internal audio buffers in those modules automatically to compensate for jitter. And so again, the beauty of the SVM3 module is I can deploy 3 QMT modules. So if somebody wants to test the waters, I mean, this is a great way of kind of conveying to them how simple this integration is. So this is a really good example, as you can see, of a hybrid solution. Add the CPM3 module if you don't have one. Add the SVM3 module, hopefully in a empty slot, and add 1 QMT. It'd be nice to have 2 QMTs. Can you observe the buffering that's automatically taking place in the system? And it's easy to revert away from this if you want to, unfortunately, go back to the good old analog backhaul method. But Also, Carol, I've had a customer also install a temporary site. So if they have a chassis that is not fully populated, they can add, like as you can see here in this particular diagram, add that SVM3, maybe add one QMT module and add another receiver with that QMT module, obviously, and then assess the performance. And this is a great way for those technicians or engineers deploying a system like this is they kind of understand how the RoIP data flows and how all the modules communicate with each other. Again, giving them confidence that they can actually deploy this on a wholesale basis on their entire system. So really the system's very, very forgiving in terms of
It's
evaluation.
good for them. It's a good way for them, Iggy, to evaluate it and have an opportunity to work with it before they do the whole changeover. You mentioned earlier that some of our customers had been operating their SNV voting system for decades on a leased line. And when I've talked to some of those that were hesitant to change, I always ask them, what are your costs, your monthly or annual costs for the leased line? And some of them didn't know, but once they checked to see what that cost was, they were ready to upgrade to an IP backhaul almost immediately. The cost in most cases is exorbitant.
Yeah, I've heard you come up with some real world examples of some of the costs, and I remember you and I were talking about a customer that has lease lines that they didn't even know they had lease lines, and they're paying for these lease lines.
Yeah,
So
exactly.
we also have another customer that their their current purpose is to move away from channel banks and T1 lines and go completely IP. And so usually, sometimes the voters usually the last to go, but cost is a big factor. You also mentioned that maybe even performance and the inability for the ISPs to want to continue supporting those type of backhaul solutions.
Exactly.
Yeah.
Yeah, you mentioned earlier about the customer installing a single site for evaluation. It's not the same verbiage that you use,
Yeah.
but you know, uh, we have some customers that ask the question. We want to conduct an active evaluation of the SNV-12 with an IP backhaul, but we're concerned if the evaluation is unsuccessful, how easy or how difficult it's going to be to revert back to the original configuration. Do you have a response for those customers that have that concern?
Yeah, just a set of slides that we showed earlier, trying to show them a simple solution as opposed to, what I think a lot of customers are afraid of is, particularly on a live channel, is that, we're going to have to take the voter down and it might take days. They might not be able to recover. So, again, having them evaluate a system and understand how these modules talk to each other. Um, you know, if we look at that single channel 12 site system, very simple, but now let's take it to the next step. We're going to remove all those SVM2 modules to support complete IP backhaul. Now that's kind of scary. So
Yeah,
um,
yeah.
again, having them evaluate in a lab setting, I think is a great way to start. A really good example was we had a customer that was going to do an evaluation. They got some modules to it, install into a site that wasn't supporting critical communications. It was a live site, conventional. It had a lot of traffic, but was not supporting critical communications. And so they elected to say, let's try to install a small subset of modules. And so they acquired the modules. They didn't install the modules promptly. And we later learned that they were a little reluctant to install the solution, the small subset of modules, because they were afraid that it might disrupt the functionality of that entire voter. So, long story short, Carol, we eventually went down there to visit that customer. I did, and to that customer site, they were going to evaluate on two remote sites, so two QMT modules, and we kind of recommend that because it shows you how, that kind of that give and take functionality between the IP links and maybe an analog links. So we went down there. We actually deployed in a lab setting in the radio shelter where the voter resides on a simple network, showed them how to provision the QMT and the SVM3 modules, did the firmware update. And so they watched the process, that very first process. And by the time I completed that first QMT1 link, and this again, this is in a lab setting at the radio shelter, they said, "Oh, that's pretty simple." And so they elected to do the rest of the additional link. Went to out to the radio sites and installed the systems. They did, and it was successful. And that led to them in a wholesale fashion updating the entire system to IP backhaul. So they just had to again test the waters, and see how simple that integration is and how reliable it was. And that there's always that doubt in their mind that if they deploy this solution, that there's no way going back. So that's no way going back and permanently disrupting communications on a live channel. So it's
yeah. We've had this happen over and over and over, where we've had customers that were hesitant to install it. Many of them were even willing to pay JPS to have a person come out and do the installation. But in every case, once one of our engineers, yourself or someone else, has talked to them and encouraged them to go give it a try, they were able to take care of it themselves. And I actually were surprised at how easy it was to do.
Yeah, I can appreciate that, because I remember at the beginning of the development of IP backhaul SVM3s and the QMT modules that I got a set of modules myself, and it was mysterious because I do have a voter in my little lab here, and I was shocked how easy it was to set up. So that's good for me, because I experienced that, and I can talk to customers and say, explain to them how simple that integration is. And really what I think we like emphasizing, us at JPS, is stage. So, set up a very simple solution in a lab if that's at all possible. So some of our customers have spare voters. I see that. I like calling those mules, lab mules, and then they can go ahead and assess not only the firmware before they deploy out to a live system, but to also understand how the relationship is created between the QMT module, the control processor module, and the SVM3 module. And you're right, Carol. I talk to a lot of customers, and a lot of them will deploy on their own. A lot of them obviously use our dealers, and some of our dealers, it's a new thing. We have a lot of SNV-12 dealers, radio dealers, that are very experienced in the SNV-12 product line, and sometimes we just have to assure them how easy it is to do that deployment. But staging, I think, to me, is really kind of the key. Make sure everything works on a very simple basis, and then begin deploying. That's exactly what happened to that customer I just mentioned. That I actually went to visit them, deployed that single link. They deployed the second link, and they discovered how simple this deployment is.
It is so important to stage any system before you go out and actually do the installation. A mentor of mine many years ago told me that when you go out to do an installation, specifically he was talking at that time about a radio system, but this applies here. If you go out and install it without staging it first and making sure it's working, 6 things can happen, 5 are bad. So you don't want those 5 bad things to happen. It makes all the difference in the world to do that. And I think that what JPS provides with all of the installation manuals and the documentation on the voter, it really takes them step by step through that process, does it not?
Yeah, absolutely. I'm glad you brought that up, because our technical writing team just came out with a new version of the SNV-12 Voter manual. It's done very nicely, so everything's consolidated. It includes all the IP backhaul addendums that used to be separate. So a lot of nice pictures and explanations how to set up. So I mean, if you're used to JPS RoIP, that client server association model that we use, the QMT module, QMT1B, and the SVM3 use that same philosophy in terms of connections. I think us explaining how IP backhaul works, a JPS IP backhaul solution actually works, kind of demystifying the process. and then having those customers actually deploy on a simple basis, really, I believe gives them a lot of confidence.
It does. You know, another resource that we have that we provide is we have done webinars and webcasts and actually training that has been recorded in the past that's currently, it resides on the JPS Interop channel. That's a
Yeah,
good resource for them as well, correct?
yeah. I mean, Carol, we did. Oh wow, this is a long time ago. We did. I think it was IP Backhaul, the network methodology. I don't know what the exact name is, but you can go to the JPS Interop channel and check that out. But we specifically talk about at a network level, not very complicated, but at a network level, we talk about how these devices talk to each other over the network and some of the port requirements. And, we talk about time sync, that has to be um, delivered over a specific port. You can change that obviously, but how does the RoIP flow, and how does one parent SVM3 module talk to three QMT 1B modules, which are separate sites? But yeah, it's interesting. Go check out. We have a lot of content on our channel talking about IP backhaul. So yeah, check that information out. And I think we're going to have some, obviously, more webcasts that talk about some of the new features that are going to come. Hopefully this year. Well, definitely this year regarding the SNV-12 Voter.
That's good news. That really
Yeah.
is. We want to thank everyone for attending today. This has been some excellent information. We hope that it's helpful to all of our attendees that have or who provide service and installation to end user customers on voters. I hope it's been helpful to you. And again, there's a lot of information on the JPS website on voters. It's on the Interop channel as well as on the website and the product section. So we really appreciate everyone being with us today on this. The next product briefing webcast will be very soon, in a few weeks, and we'll send out notices ahead of time, letting you know what that webcast is going, when that webcast is going to take place. The next one is going to be on push-to-talk over cellular integration. We're going to talk about standalone RSP-Z2 solutions, wide area solutions, and some of the hurdles that you may not understand currently, but we want to walk you through those different situations, and including the placement of the donor radio. But we'll talk about that in the next webinar, and we're looking forward to doing that. I think it's going to be a little eye-opening because of all of the new firmware upgrades we've had to the RSP-Z2 recently, and there's another one coming out. So anyone that has RSP-Z2s, or someone, if they're looking at buying some of these RSP-Z2s to use for push-to-talk over cellular, this is a webinar that they don't really want to miss, isn't it, Iggy?
Yeah, it's going to be sort
Yeah.
of in line with what we just, I believe what we just did. Talk about, some of the questions customers um, present to us regarding IP backhaul. But I think what we're going to talk about in terms of push to talk over cellular is some of the gotchas. I mean, we've seen a lot of gotchas, and we've experienced a lot of different situations where the solution didn't go as smooth as we like, because we're dealing with lots of, I guess, different parties. You got JPS, obviously, then you have the push to talk over cellular service provider, then you might have to be involved with the customer that might be at a facility, the network administrator, the firewall administrator. So there's a lot of people, a lot of personalities in play. So we'll talk about some of those hurdles and how we try at JPS to avoid getting stuck in a sort of a loop, kind of a blame game. But there's things to look out for that a lot of our customers that deploy IP backhaul, particularly those that aren't very technical, might miss. So we'll talk about that. Again, it's related to some of the issues we've seen, and some of the things to watch for when deploying a push to talk over cellular service.
I'm excited to do that one because we have had some unique situations where we have sold the RSP-Z2 for use to push to talk over cellular, and the specific applications that we've dealt with made it somewhat difficult to navigate through some of those other parties, the third parties. But I think we've learned a lot in doing that. We found some ways to get around that. We'd like to pass that on to our customers. This has been an excellent discussion. I've really enjoyed it, and I appreciate seeing some of the new things that Iggy has provided today. Excellent slides. They're very intuitive and self-explanatory. Thank you for doing that, Iggy.
You bet.